Hey guys, today's video is about Naïve Bayes. There are three main topics: probabilistic classifier, Naïve Bayes classifier, and Laplacian correction. To keep the video short, we'll only discuss probabilistic classifier today. To begin with, probabilistic classifier predicts the probability of a tuple belonging to a certain class. The importance here is that we are now talking about the probability. Like a person has 60% chance buying a computer. In other words, the model doesn't directly predict whether a person will buy a computer or not. It just estimates the likelihood. The advantage of a probabilistic classifier is the high performance in terms of accuracy, and its performance is compatible with decision tree and even neural networks. However, the disadvantage is the low interpretability. Unlike decision tree, we don't have a path to follow, so it's sometimes hard to speculate how the model makes a prediction. The reason why we care about this is that Naïve Bayes is one of the probabilistic classifiers. Before we can discuss Naïve Bayes, we have to understand some basic terms of probability theory. First, event is a subset of outcomes of a random experiment. For example, assuming the experiment is rolling a die, then all possible outcomes are 1, 2, 3, 4, 5, and 6. Then, events can be 1, or the union of 2 and 5, or any combination of outcomes. Second, event space is the set of all possible outcomes. As you can imagine, the set 1, 2, 3, 4, 5, and 6 is the event space of rolling a die. Third, probability of events is the probability of observing a certain event. For instance, the probability of observing 1 from a dice roll is 1 over 6, assuming the die is fair. Then, the joint probability is the probability of observing multiple events. To illustrate, the probability of observing 1 from the first dice roll and observing 2 from the second dice roll is 1 over 6 times 1 over 6, which is 1 over 36. We just multiply the probabilities because the two events are independent. In other words, they are unrelated. The occurrence or absence of an event won't affect another. There are a few symbols that are commonly used to represent these terms. We typically use capital X and Y to denote an event. P of X represents the probability of event X. P of X and Y is the joint probability of events X and Y. Now we can discuss the conditional probability. Conditional probability is the probability of observing event X given Y has occurred. Therefore, the symbol here means given event Y, not the mathematical symbol or. The formula of conditional probability is P of X and Y divided by P of Y. That is, the joint probability of X and Y divided by the probability of Y. Let's look at an example. Say we have this database which records the gender of a person and whether the person buys a computer, and we want to know the probability of a person is male given that person buys a computer. So, we just plug in a formula, joint probability of male and buying a computer, divided by the probability of buying a computer. We start with the numerator. What we do is just finding the corresponding column and row. Then, we find the number of people that are male and buy a computer, which is 40. Now, we deal with the denominator. Since we only need to find the probability of a single event, we look at the whole column, and we sum up the numbers in that column, which turns out to be 60. That's it. The conditional probability is 40 over 60, which is 2 over 3. In fact, we just figure out 2/3 of people who buy a computer are male. Alright, that's the background we need to know before looking at Naïve Bayes. Thank you for watching my video and see you soon.